Okay, here's your video for 13.2. 13.2 is all about like the features of quadratics, meaning can you talk about vertex form in all of its different ways? We can talk about vertex form from the equation, vertex form from a chart, vertex form from a story, vertex form from a graph, right? So it's all vertex form in different kind of ways. So the first one's going to be vertex form from a story, and then I'll do each of these too, just so that I think that could help. All right, so we've got a bird sells t-shirts outside of Wrigley Field before every game. Obviously, this was probably supposed to be a flight of a bird, but it's not any of that. So let's just say a boy sells t-shirts outside of Wrigley Field before every game. He finds that if the price of a t-shirt is set at X dollars, then the profit from a week's sales is modeled by blah, blah, blah. Okay, so this is sort of about t-shirts, making money, shirts, money. I heard the word profit in there somewhere. Okay, so let's see if we can answer the question. Determine the vertex. No problem. Here's my equation. In a vertex form, you can just take the vertex by taking the opposite of the number in parentheses, and then we keep the number in the back the same. So this number changes sign. Whatever's with X matches X, because again, in an ordered pair in this thing, this is always first. That's the letter X. And so what's with X inside the parentheses is -3, but there's a sign change, and then keep that number in the back. Okay, so now I need to explain it. Explain means words, right? So we need 33 to have words. So the 33 represents the X, and somewhere in this story, somebody had to tell me what X was. So I'm just going to reread the story. Boy is selling t-shirts. He finds that if the price of a t-shirt is set at X dollars. Okay, I got it. So X represents the amount of money. This is dollars for a t-shirt. Okay, then I'll keep going. The 10,935 must be something else. And let's see if it tells me. It says the profit. All right, so this is the profit. Okay, so the 33 represents the price of a t-shirt, and the 10,935 represents the profit. So I'm just going to turn that to a sentence. So if you sell t-shirts for $33, the boy will earn a max, I'm going to throw that word in there, profit for 10,935. Because remember what this is. This is a parabola that's facing upside down, and it peaks at the vertex. So that's your max profit. All these other profits are below that and below that. So if you want to throw the word max in there, that's even better, because the vertex is the maximum of this parabola. And if this parabola is facing upside down and it peaks here, that's important. That means this guy, this boy, will never be able to sell more than that. So if he prices his t-shirts at $33, he's going to hit maximum profit. And that's what that's saying. But again, it starts out with noticing how to make the vertex from the vertex form, and then knowing which words are associated with each of these. And then again, it has to tell you something in the equation. Okay, now we've got this chart. Chart asks us for the same things it has all semester. Y-intercepts, X-intercepts, the vertex, right? So the first thing I'm going to find is the Y-intercept, because I'm looking for something to have an X of 0. That doesn't change whether we're looking at a chart or an equation. Find an X of 0, and that's your Y-intercept. So 0, -3. The X-intercepts have a Y of 0, so now I'm just looking across and trying to find some Y's of zeros. And that's going to be 3, 0, and 1, 0. And then my vertex, if you guys remember from Unit 11 or Unit 12, is always in the middle of my x-intercepts. So if I look at the middle exactly of these 2 points, the middle is going to be right here at -1, -4. It's in between exactly. It's 2 boxes away from -3, and it's 2 boxes away from 1, so that way it's exactly in the middle. So this is the middle of x-intercepts. You can say this. You can also say something like, I notice that these numbers are decreasing, and all of a sudden the numbers are increasing, and that turning point happens here. So the numbers are doing something, like they're 0 to -3, -3 to -4 means the numbers are going down, and all of a sudden the numbers reverse and start doing the opposite thing. We call that a turning point. So it's the turning point. You could say something like this. Or you could say something, it's like the minimum or the lowest number, because that's what a parabola will have. It will either have a lowest number if you have this, or it will have a highest number. So you can call it a maximum or a minimum. Or you can also do the symmetry thing. So if you notice, -3 and -3 are a match, 0 and 0 are a match. If we kept this going and connected these like kind of smiley face rainbows, 5 and 5 would go here, 12 and 12 would go here, 21 and 21 would go there. So -1, 4 is the only one that doesn't like make a match, because it's right in the middle, and that's what a vertex is. This has a match here, this has a match here, this has a match here. The only one that doesn't have a match is that vertex. So you can say something like, it's the only non-symmetrical point, meaning it doesn't have a match. Everything else is matching. So I don't care what you say. I think the middle idea is really smart because it connects back to what we did last unit, where this is exactly in the middle of your two greens, and your greens are your x-intercepts. But any of these options that I just mentioned would have been just fine too. Okay, one last one here. Okay, determine the positive x-intercepts and then explain the meaning of the story. All right, so I've got this water balloon launching out of a window, blah, blah, blah. Determine the x-intercepts. Oh, it says determine the positive x-intercept. That's this guy here. I think that's 4.5. This is 5, because this is 6. So that's 4, that's 6, that's 5. That must mean 4.5. So 4.5, comma 0. And then explain the meaning and context. The story is always going back to words, right? So 4.5 is your x, 0 is your y, and then I have to tell you about that x and the y, and I'm just going to use the labels because they're already there. That's 6 on the bottom across the x, that's time. And then the height in feet on the side. So this is telling me that at 4.5 seconds, the height is 0. Okay, well, 0 really means the ground. So really what this is saying is that the water balloon was on the ground, or at 0 feet, whatever you want to say there, after 4.5 seconds. Okay, so I'll do the same thing here. Let's explain what this means. This is the x, this is the y. If I go to where the x-axis is, I see the label of time, right? This one's the x-axis, there's time. What's on the y? Height. So again, what this tells me is that the water balloon was 86 feet in the air at 3 seconds. So 3 seconds after I threw this water balloon, all of a sudden this water balloon was just hanging out 86 feet in the air. All right, and our last one, what's the domain in the context of the situation? Reasonable domain. Okay, so think about what we've been talking about, theory versus reality. A parabola, in theory, goes up and down forever. It either goes up forever or it goes down forever. But even if you think about a water balloon does not go up forever, but it definitely doesn't go down forever either. Same thing with a rocket ship or anything else that you throw in the air, right? If you throw it and it comes back down, it's not going down forever. So this is where theory and reality differ, because if I put the equation into Desmos, it's going to make me a parabola that goes down forever. But in reality, that's not what's happening. So when I ask you for a reasonable domain, I'm asking you about the x-axis, which in this case is time. What's a reasonable time? When does this story start? And when does the story end in reality? We're talking about totally in real life. So in reality, the story, I think, starts at 0 seconds. Most stories start at 0 seconds. And the story ends, I think, here. And that's going to be my 4.5. Right? So that's my reasonable domain. If I had a different story that looked something like this, and this is 0, and this is like 10, And I would say, what's a reasonable domain? I'd say, well, 0 seconds and 10 seconds, because after 10 seconds, this thing is going into the ground, which makes no sense. In reality, the picture should look something more like this, like it should stop in that little section here. Oh, that's going to delete it. Partial, thank you. Right, like that shouldn't be there. We should just be able to magically erase it. And we can. When we say what's a reasonable domain, that's what we're doing. We're like erasing the part of the picture that doesn't make any sense. And remember, reasonable domain is always going to be with these numbers here. So wherever it makes sense on the timeline on the x-axis. Okay, I hope that helps with 13.2.